linear inequalities here. Clearly x greater than 0, y greater than 0 indicates the solution will be in our first quadrant. The distance of B from x-axis is 2, that is this is the distance, and distance from y-axis is 3, so therefore its coordinate is 2, 3. The minimum value of z is 300 at the point 60, 0. We call minimum value as an optimal value for this function, and a4, 0 is the optimal solution. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So here in this session, we are going to take few more problems on linear programming problems, that is finding the solutions of LPP through graphical method. So the first question is minimize z is equal to minus 3x plus 4y subject to the constraints x plus 2y less than or equal to 8, 3x plus 2y less than or equal to 12, and x greater than 0, y greater than 0. So now we know that what are the steps to follow while solving the linear programming problem. So whenever the linear function is given, that is function which has to do is we have to find the minimum value of the linear function. How to do this? By solving the linear inequalities with the help of a graph. Now we have linear inequalities here. Clearly x greater than 0, y greater than 0 indicates the solution will be in our first quadrant. Now let us solve x plus 2y is equal to 8. So let us take the coordinates x and y. So if you put x is equal to 0, we get 2y is equal to 8. So y is equal to 4. If you put y is equal to 0, you will get x as 8. So the coordinates for the first inequality is 0, 4 and 8, 0. Next we will take 3x plus 2y is equal to 12. Again here, when you take the coordinates x and y, if you take x as 0, you will get y as 6. If you take y as 0, you will get x as 4. So therefore the coordinates are 0, 6 and 4, 0. Now let us plot these points and draw a straight line for the both inequalities. So the first one, you can clearly see the points for the first one, x plus 2y is, the first point is 0, 4. So this is the point, and the second point is 8, 0. So using your scale, draw a straight line for this one, and for the second inequality, the points are 0, 6 and 4, 0. So again here, join the 2 points using the scale. Now coming to the shaded region, here I have already shaded, this will be the feasible region. So how to find out? So clearly you can see we have less than or equal to, less than or equal to. That means if this is a straight line, for both the lines, the solution region will be below the straight line. So for this line, the area under the line denotes the solution region, and for this line, the area under the line denotes the solution region, because it is less than 8 and less than 12. Now we have to find the region where the two region can combine so that it is the solution region for both the lines. Hence, here the shaded region is the feasible region or solution region. So in your examinations also you have to shade this region. So which means a feasible region combining the solution of both linear inequalities. Now once you got the feasible region, your next step is to mark the corner points. So what are the corner points you have? So these are the corner points. So which I have taken as O, A, B, C. Now origin is already 0, 0. A is already you know that is 4, 0. C is already you know that is 0, 0. Now to find B, here I have written 2, 3. That means the distance of B from x-axis is 2. That is, this is the distance. And distance from y-axis is 3. So therefore its coordinate is 2, 3. Now once you found all the corner points, substitute it in the corner table. What is the next thing you have to do? You have to take all the points and solve the linear equation given and find the minimum value. So here I have taken all the corner points in one column, origin A, B, C, and our equation is z is equal to minus 3x plus 4y. So substitute the value of x and y in each corner point, you will get the value. Now clearly for origin, z becomes 0. For 4, it is minus 3 4s are minus 12, 4 zeros are 0, hence it is minus 12. Next it is minus 6 plus 12, which becomes 6. Next it is 0, 4 4s are 16, so the value is 16. Now here we need to find the minimum value. So which is the minimum value here? So minus 12 is the minimum value. So thus you have to conclude here, the minimum value of z is minus 12 at the point minus 12 at a4, 0. Hence we call minimum value as an optimal value for this function, and a4, 0 is the optimal solution. Next, minimize and maximize z is equal to x plus 2y subject to the constraint x plus 2y greater than or equal to 0, 2x minus y less than or equal to 0, 2x plus y less than or equal to 200, and x comma y greater than 0. Now my aim is to find both minimum as well as maximum value for the given linear function by solving these linear inequalities. And here x comma y greater than 0 indicates the solution region lies in the first quadrant. Let us see what are the points or what are the coordinates we will get for these three linear inequalities. The first one is you have x plus 2y is equal to 100. So now let me take the value of x as 0, then I'll get 2y is equal to 100, so y will be 50. If I take y as 0, x will be 100. So therefore, what are the coordinates for the first line? 0, 50 and 100, 0. Second one, you can clearly take it in the form of 2x minus y is equal to 0, which implies y is equal to 2x. So here, again taking the value of x and y here. So put x is equal to any value. So you can take 50 also. Y is, you will get it as 100. And if you take x as 100, then y you will get it as 200. So you can take any value for x, your y will be double the x. So you can take 10, you will get 20. You can take 20, you will get 40. The next one is 2x plus y less than or equal to 100. Now let us solve 2x plus y less than or equal to 100, or we can take equal to 100. Now again find the solutions for x comma y. So if x is 0, your y is 200. If y is 0, your x is 100. So what are the points here? We can take 0, 200 and 100, 0. Now let us plot these points in the graph. So taking x and y axis. So since clearly you can see all the points in terms of 50, 100, 200. So I will take the x axis and y axis in terms of 20, 40, 60. 20, 40, 60. So let us plot this point. The first one is 0, 50, 100, 0. So clearly you see for the first line I have taken 0, 50 here. So between 60 and 40, 0, 50 and 100, 0. So this is the line for x plus 2y is equal to 100. My second line, as I said, if you take 50, the value is 100. So if you take 20, the value is 40. If you take 100, the value will be 200. So minimum 2 points is necessary. So let me take the straight line taking this. So we can say this 20, 40, 50, 80. Joining this line, we will get the equation for 2x minus y is equal to 0. The third line coordinates is, the first coordinates is 0, 200. The second one is 100, 0. So join the third line whose inequality is 2x plus y less than or equal to 200, and this is a straight line, so 2x plus y is equal to 100. Now again to find the solution region. See here, The first one is greater than 100. So that means your solution region will be above the line. So look here. So this is the line here. The solution region will be above the line. So that means the area above the line indicates the solution region. And for these two lines, the solution will be towards the left because they have less than. So we can clearly say 2x minus y less than or equal to 0 means 2x is less than or equal to y. So therefore, for this line, the solution will be behind the line. And for this line also, the solution will be the region below the line. But which is the region which is satisfying all the condition, which is a common region which satisfy all the linear inequality? So here, the shaded region indicates the solution region for all the three inequalities. Clearly, you can see for this line, the area is above the region. So for this line, it is behind, and for this line, it is below. So that's why this region will indicate the solution region or feasible region for the given set of linear inequalities. Now, once you found the solution region, the next thing is you are supposed to mark the corner points. So, already the corner points are marked for the three of them, and this one how you can get, you will get by x distance as well as y distance. So, therefore, B is 20, 40. C is already known, D is already known, and A is 0, 50, which is already known. Substitute all these in terms of corner point table by taking corner points in one column and your function in another column. Take all the points in terms of x and y, substitute in the linear function, find the values for z. So, first one 0, 50, you will get z as 100. 20, 40, you will get z as 100. 50, 100, you will get z as 250. 0, 200, you will get z as 400. Now, my aim is to find out both maximum and minimum value for this linear function. So, here you can clearly see which is the minimum value. So, minimum value exists here at 2 points. So, therefore, 100 is the minimum value. Which is the maximum value? Maximum value is 400. So, thus we can clearly conclude that the maximum value of z is 400 at D 0, 200. Next, the minimum value is 100 at A 0, 50 and B 20, 40. So, this is the solution for the given linear programming problem. Next, minimize and maximize z is equal to 5x plus 10y subject to constraint x plus 2y less than or equal to 120, x plus y greater than or equal to 60, x minus 2y greater than or equal to 0 and x greater than or equal to 0, y greater than or equal to 0. So, let us find the solution for these linear inequalities. X plus 2y is equal to 120. So, solution we'll take it in the form of x and y. So, if you take x as 0, you will get y as 60. If you take y as 0, you will get x as 120. So, therefore, the coordinates are 0, 60 and 120, 0. For the second one, you have x plus y is equal to 60. So, we have x and y. X is 0, y 60, y is 0, x is 60. So, therefore, it is 0, 60 and 60, 0. Next, we have x minus 2y is equal to 0. So, this implies x is equal to 2y. Now, let me take the solution. So, what is the value you take it for y? X is double the y. If you take y as 20, your x is 40. If you take y as 30, your x is 60. So, now after plotting each line, so this is the graph you are going to get here. So, we can clearly see we have drawn a straight line for all the solutions here. So, this is the equation x plus 2y is equal to 120. So, this is x plus y is equal to 60 and this is the line x is equal to 2y. Clearly, I have mentioned the feasible region because for this line, the linear inequality says here for first equation it is less than 120, the other two is greater than 60 and greater than 0. So for the first set of line, we can clearly see the solution region is below it because it is less than 120. And for the second set of line, it is greater than 60. The region will be above the line. And for the third set of line, it is greater than 0. That is, x is greater than 2y means it is below this region. So this will be the common region, which is a feasible region. And once you find the feasible region, you can mark the corner points here. So the corner points are given here and it is taken in the table. So what are the corner points we have in the figure? 60, 0, 120, 0, 60, 30 and 40, 20. So clearly you see here I have written all the corner points and this is our function 5x plus 10y. Substitute x and y values in each case and find the value. So z is equal to 300 for point 60, 0, 600 for 120, 0 and 60, 30, 40, 20, it is 400. So which is the minimum value here? We can clearly see 300 is the minimum value and 600 is the maximum value. Therefore, the maximum value of z is 600 at the points B 120, 0, C 60, 30. And the minimum value of z is 300 at the point 60, 0. So next problem. So until here, the linear programming problem which has formulated was given. So and here we are going to formulate the mathematical linear programming problem with the help of the statements given. So the question is given here, one kind of cake requires 200 grams of flour and 25 grams of fat. Another kind of cake requires 100 grams of flour, 50 grams of fat. Find the maximum number of cakes which can be made from 5 kg of flour and 1 kg of fat, assuming that there is no shortage of other ingredients used in making the cakes. So here, let me take cake A and cake B. Cake A, so cake B. And here, flour required and fat required. Next, I will write here availability. So for cake A, you require 200 grams of flour and 25 grams of fat. For cake B, you need 100 grams of flour and 50 grams of fat. But availability of flour is 5 kg, which is nothing but 5000 grams. And 1 kg of fat, which is 1000 grams of fat. So remember, when you have a grams and kg, convert everything into only one unit. So here, using 5000 grams of flour and 1000 grams of cake, how many cakes can be made? So that can be formulated in this way. So that is, maximize z is equal to x plus y. X represent cake A, y represent cake B, that is number of cake A and number of cake B. So using the constraints of flour as well as fat, so that is cake A can use 200 grams of flour and 25 grams of fat. Cake B can use 100 grams of flour and 25 grams of fat. So we can convert the linear equation for flour as well as fat. So what is the maximum availability of flour here? 5000. So we can use 200 grams for X cake, 100 grams for Y cake. So that maximum it can get is 5000. So clearly you see here 200X plus 100Y cannot have more than 5000 grams of flour. Similarly, the fat is 25 grams for cake A, 50 grams for cake B. So I can use 25 grams for X cake and 50 grams for Y cake, and it cannot exceed more than 1000 grams of fat. And when you solve this linear inequality, so divide throughout by 200 here. So divide this equation by 100. 100, this becomes 2x plus y less than or equal to 50. And here divide the equation by 25. So it becomes x plus 2y less than or equal to 40. So this is the mathematical formulation of the given problem. So you have to write the formulation of LPP and then solve it. So we can clearly see we have to find the maximum number of cake which can be made using 5 kg of flour and 1 kg of fat. So these are the linear inequalities we have to solve. Now again we have 2x plus y less than or equal to 50. So let's take the solution using graphical method. For that we need to find the coordinates for both the linear constraints here. So for the first one I am taking here x and y. X is 0, so you can take y as 50. If you take y as 0, so x is 25. So therefore it is 0, 50 and 25, 0. The next one is we have x plus 2y less than or equal to 40. And when you solve this linear equation in terms of x and y, if you take x as 0, you will get y as 20. If you take y as 0, you will get x as 40. So therefore clearly you can say here it is 0, 20 and 40, 0. So now after plotting this in the graph, this is what we will get. So for the first line, clearly you can see this. So now this is the graph we will get for 2x plus y is equal to 50. That is 0, 50 and 25, 0. Draw a straight line. The next one is 0, 20 and 40, 0. Draw the second line. And clearly we can see both are less than or equal to, which means the area will be below the line. So this is the region which satisfies both the condition and hence this is the feasible region. Once you mark the feasible region, next you are going to find the corner points. So the corner points here are 0, 0, 25, 0, 20, 10 and 0, 20. 20, 10, again you will get the distance from x-axis is 20, the distance from y-axis is 10. So which is the coordinate of point B. Now substitute all these in the corner point, solve it for x plus y. So see which is the maximum value here. So this is our maximum value at the point 20, 10. So I said x, y. Coordinates are in terms of x, y. X means number of cake A. Y means number of cake Y. So using 5 kgs of flour and 1 kg of fat, we can prepare maximum of 30 cakes where 20 pieces of kind cake A and 10 pieces of kind cake B. So therefore, maximum number of cake. So maximum number of cakes which can be made is 30, of which cake A is 20 and cake B is 10. So this is how we can use the linear programming. So whenever we have certain types of quantity and we don't know how much quantity we can prepare and what are the kinds of quantities and we can prepare here. So this is where it helps us. So the maximum product using the constraints we can use here or using the fat and flour we can prepare here is 30. So without wasting any ingredients, we can prepare 30 cakes where 20 cakes will be of cake A and 10 cakes will be of kind cake B. Next one, a cooperative society of farmers has 50 hectares of land to grow 2 crops X and Y. The profit from crop X and Y per hectare are estimated as rupees 10,500 and rupees 9,000 respectively. To control weeds, a liquid herbicide has to be used for crop X and Y at the rates 20 liters and 10 liters per hectare. Further, no more than 800 liters of herbicide should be used in order to protect fish and wildlife using pond which collects drainage from this land. How much land should be allocated to each crop so as to maximize the total profit of the society? Solve the following linear programming graphically. So clearly see, we have only 50 hectares. So we have to distribute the land here for both crop X as well as crop Y. And they have given the profit from crop X is 10,500 and from crop Y is 9,000. So when I say we can grow crop X only, the maximum profit, how much maximum profit we can get, and when I say when I can grow crop Y, how much profit we can get, or when I combine them and grow them, distribute the land for crop X and crop Y, what is the maximum profit I can get? So that we have to calculate. And here the conditions of land is given. Only 50 hectares are provided, so we have to distribute for both crop X as crop Y. But how to distribute? We will see through the linear programming. The next one is, there is a condition for liquid herbicides. What they have given here, only 20 liters has to be used for crop X and 10 liters has to be used for crop Y, but there is only 800 liters. So without wasting it, we have to distribute the liquid herbicides for both crop X as well as crop Y also. So using the land constraint and using the herbicides constraint, we have to distribute the land of 50 hectares for both crop X and crop Y. So how many maximum profit we have to get? So when I say maximum, my aim is to maximize the given problem. So we know that for crop X, it is 10,500. But how many land? So here X will give you how many hectares of land. So for per acre, if you get 10,500, for how many hectares you will get 10,500, which is 10,500 into X. And Y represent number of hectares for land crop Y. So 9,000 Y. So this is the maximum profit in terms of amount and land. Now the land constraint, as I said, it is X plus Y less than or equal to 50. Liquid herbicides, here it is in the solved problem. But here actually it is 20X plus 10Y less than or equal to 800. That is 20 liters for crop X, 10 liters for crop Y. But here 20 liters for crop X means X represents 1 hectare of land and Y represents 1 hectare of land here for crop Y. So that cannot exceed more than 800. When you divide it by 10, you will get the equation 2x plus y less than or equal to 80. Now solving this linear equation, we will get the graph in this form. So for the first linear equation, set of equation, when I say 2x plus y less than or equal to 80, when you put x is 0, y is 80. So the first point is 0, 80 and the second point is 40, 0. So join the straight line. The next one is for the x plus y 50, 0, 50 and 50, 0. So therefore 0, 50, 50, 0. Clearly we know that both are less than or equal to because we are finding the maximum value which cannot exceed 50 hectares and 800 liters of herbicides. So therefore the shaded region here will give you the feasible region, that is the solution region. Now you have got the solution region, mark the corner points here. So what are the corner points we have? Origin 0, 0, A 40, 0, B 30, 20, 30 in terms of x-axis, 20 in terms of y-axis. You can recognize it with the help of graph and C is 0, 50. Now substitute all this in the linear function. So what is my linear function? 10,500 rupees for 1 hectare. So for x hectares, it is 10,500 x. 9,000 into y hectares. So now substitute. So now here 40, 0 if you take, it is 4,20,000 in terms of rupees. Now 30, 20 if you take, 4,95,000 in terms of rupees. Now 0, 50 if you take 4,50,000 and 0, 0, 0. What does it means? So 40, 0, as I said, x, y, x represent number of hectares for crop X and Y represent number of hectares given to crop Y. So if 40 hectares of land is given to crop X, the profit you can gain is 4,20,000. If I distribute 50 hectares of land for 30 hectares for crop X and 20 hectares for crop Y, then the profit I can get is 4,95,000. Similarly, if I give all 50 hectares for crop Y, we'll get 4,50,000. And if none of the hectares were given, obviously the profit is 0. So we usually think whenever crop X can gain 10,500 rupees profit, we can grow completely crop X on all 50 hectares of land. So that is a myth where we cannot satisfy that condition, and hence LPP helps us to find these kind of problems. So clearly you can see here from the corner points we can see where we are getting the maximum profit and how we can distribute the land. So therefore here the maximum profit you can gain is 4,95,000 by distributing 50 hectares land to 30 hectares for crop X and 20 hectares for crop Y. Next problem, a manufacturer produces nuts and bolts. It takes 1 hour of work on machine A and 3 hours of work on machine B to produce a package of nuts. It takes 3 hours on machine A and 1 hour on machine B to produce a package of bolts. He earns a profit of 17.50 per package of nuts and rupees 7 per package of bolts. How many packages of each should be produced each day so as to maximize his profit if he operates his machine for at the most of 12 hours a day? So here a manufacturer is producing a nuts and bolts. So if he sells a packet of 1 nuts, he will get the profit of rupees 17.5 rupees. If he sell a package of bolts, he will get the profit of 7 rupees. Then the condition is to prepare a package of nuts, there should be 1 hour work on machine A and 3 hour work on machine B. And to prepare a package of 1 bolt, there is a 1 hour of machine B and it takes 3 hours on machine A. So there is a condition of machine A as well as machine B, and it cannot exceed, that is the machine cannot operate more than 12 hours in a day. So using that restriction and by seeing the profit of each packet of nuts and bolts, we need to find the maximum profit with the given constraint. How to formulate this? Now clearly for nuts and bolts, so I'll take machine A and machine B. So nuts, machine A, it takes 1 hour, machine B 3 hours. And for bolts, it is 3 hours and it take 1 hour on machine B. Availability of machine A is maximum 12 hours. Availability of machine B is also maximum 12 hours. So when I turn this equation, I'll get it as x plus 3y less than or equal to 12. And here it becomes 3x plus y less than or equal to 12. What is the thing I have to see? So the cost, we have to maximize the profit where I'll get 17.50 for x package of nuts and 7 rupees for y package of nuts. This is my linear function. So I need to maximize this by using this linear constraint. So the formulation of this statement is here. Maximize z is equal to 17.5x plus 7y subject to constraint x plus 3y less than or equal to 12, 3x plus y less than or equal to 12. So here the graph is given. So to solve x plus 3y is equal to 12 here, if you put x 0, you will get y as 4. So 0, 4 and 12, 0. So 0, 4, 12, 0, draw a straight line. For the second line, 0, 12 and 4, 0 will be the solution. Draw the line. So this will give you the feasible region. Once you find the feasible region, mark the corner points, write the corner points. So 0, 0, 4, 0, 0, 4 and 3, 3 you can see x distance is 3, y distance is 3. So therefore point B is 3, 3. Now substitute in the corner points. See where you are getting the maximum value of z. So clearly you can see here 4, 0. That means 4 package of nuts and there is no package for bolts, you will get rupees 17 as a profit. 3 package of nuts, 3 package of bolts, you will get rupees 73.5. So 4 package of bolts only 28. So 0, 0 means it is clearly zeros. Now you see decide here which is the maximum value. So this is the maximum value. So what does it mean? So we will get a maximum profit of rupees 73.5 by preparing 3 package of nuts and 3 package of bolts in a day. So this is where it helps to decide where to maximize profit, where to minimize the cost, where to minimize the requirements. So this is how we are going to solve the linear programming problem. So we'll meet you in the next session with few more linear programming problems. Until then, keep watching, keep learning, keep exploring. Thank you.